Howdy folks, welcome back to Advent of Code 2024. We are looking at day 5. So we got here. Okay. We move on to subbasement 17. A printer. Sleigh launch safety manual updates won't print correctly. Okay, cool. New pages for safety manuals must be printed in a very specific order for safety. Addition X bar Y means that if both page number X and page number Y are to be produced as part of an update, page number X must be printed at some point before Y. The alpha has to read both the page ordering rules and the pages to produce in each update, but can't figure out whether each update has the pages in the right order. Okay, so here's 47 must be before 53, 97 must be before 13. Kind of an odd printer, but okay. And here's the actual updates. The first section specifies the page ordering rules, 1 per line. The first rule means an update. Okay. Numbers of each update. Pages need to update through different too. Okay. Okay, the first update is in the right order because the rules put each. Okay, so each page after. Oh, so that means for 75, we need to make sure 47, 61, 53, and 29 all come after 75. Okay. Okay. And then that one, okay, and then 74 before it. But I mean, honestly, if you've already verified this case, you kind of know that this is true. So it's kind of like, as you're moving along each letter, you don't have to, or page, you don't have to look at the ones behind it because you've already validated those. Possibly. Unless there's a case where there is a rule that, like, for example, we find the rule 7529, but that doesn't exist, but there is. No, I guess that wouldn't make sense. You couldn't have it go the other direction. Never mind. Okay, cooking out. And this is 74 before it, and these two are after it. Okay. Oh, so there is that. Yeah, okay. That makes sense. Alright, the only page left is correctly last. That makes sense. Because the final update does not include some page numbers. The ordering rules are ignored. Okay, that is not the correct order. Puts print, which violates that rule. Okay. The middle page number of each update being printed. The middle page number, okay. Okay, so you get the middle page numbers and add them all together. That's not too hard. That's not a difficult thing to do. The thing I would, well, yeah, it looks like these are all odd. If they're even, then you have to be you have to think about what is middle. Because then you have to, does it fall on this side or this side? With odd, it's always very clear what's in the middle. Okay. Right. Obviously, it's bigger, more complicated. Okay. So, let's start off with this as our example. So this actually has two chunks of data, which is going to be kind of interesting. We have to find an empty thing here. FS. All right, so let's just get all our data into start. txt. Sync and yeah, that is correct. That's what I want. All right. So now that we get all those contents in, we could do this because we know we're going to get 2 new lines, and I don't think, yeah. So we could actually do this. We could say page rule string updates string equals contents.split, and I'll just split by 2 new lines, like so. Let's just see if see, I'm getting some heat, but I think we're doing okay so far. 3, 2, 1. This is going to give us those 2 hopefully split out. Let's just double check that. Update string. Okay. I'll get my terminal here. Node. Oh, update string is not, you know what? That is true because it's update string. Okay. First part. Yeah, second part, and that should be fine. Okay, So now let's get our page rules. Rule split. Page rules list. And so what I'm going to do here is I want to actually have kind of a map. I want to know for a specific number all the ones that come after it. I think that, well, there's a couple ways to do this. One, because we need to actually know for each pair if that pair exists. So 75. So it might actually be better. Actually be better just do a map of these like so. Map. And then map. Okay. So what are we doing here? Why are we doing this? The idea here is that we're going to end up with a map. I'll just console log it. Map. And it just has all these lists with true, which there's a way to do it. Because when I'm looking up this, when I'm looking through these, I really want this relationship, then 75, 61, 75, 53, 75, 29. I want that specific relationship. And I want 47, 60, 47, 53. So I really want this actual, just this is the key. I could make it with like 97 as the key and then all these as an array, but that's actually more work because then I have to get out that list and then process over it as a list, right? Which I don't really want to do. So I think this is better. Okay. Now, updates array. Okay, we'll split that. Okay, and update items equals. Oops. I want to split this one too. I think on the comma. Yes, on the comma. Split. Okay, and I don't actually need to convert these to a number because I've just got string keys, so that should be fine. And now I'm actually just going to do a double nested loop over these because really I need to compare this against everything after it. So, and update items to length I++, and then for j, let j equals 1. Oops, I. J, update items to length. And what this ensures also, oh, there we go. This I don't want, but so this is basically going to say, that's more correct. We go from 0 all the way. This is I+1, which is totally fine because we don't want to actually check itself because it shouldn't have a rule for itself. What that's going to mean, though, is this gets just ignored completely, which is fine. Like the inner loop won't even run for that, which is totally fine because we don't need the inner loop to run for it since it's by itself and just everything should be built for it, but that should be checked by everything else. Okay, so yes, conflicting rules for key. Just see what that does for now. Okay, cool. We get some errors there. So now what we're going to do is, again, we're going to use a sentinel. And we're going to use, oopsie. We're going to use a true one, and then is valid equals false. And of course, we're going to break immediately after that. And now, after the loop, is valid. I'm just going to console log the update for now. Okay. Oh, so we didn't get any of them invalid. Okay. Let's console log the keys here. So 7547 is definitely there. I'm pretty sure, yeah, so that's there. So why didn't we find that one? Oh, so I did this backwards. So it should be if not page rules. So if we didn't find it. So I'm just saying, oh, if you did find it, it's not valid. Dumb. Okay. Now we've got a couple there. So let's get rid of that log. Okay, so we've got this one, this one, this one. Let's see if that's accurate. This first one is correct. Okay. The first upgrade, okay. The second and third are also correct. Fourth, fifth, and last are not. Okay. So that looks correct because we only got those first three, and the second three were bad. They need to know the middle page number added together. Okay. So let's see. Oops, let's do this let. And in this particular case, we are actually going to need to, once we find the middle, we're going to need to convert it to an integer. So let's see, middle equals, so let's say we have 5, the middle is going to be at 0, 1, 2. If we have 3, the middle is going to be at 0, 1. So it's basically going to be the size divided by 2 rounded down, which is going to be update items dot length divided by 2, and then we will math dot floor it. Round it down. Okay, middle equals parse int, update items, middle index. The 10 here is just the radix or the base to convert it to. Total middle plus equals middle, and then is I middle. All right, let's see what we get. 143. 143. Okay, let's try it with our actual input then. Well, yeah, a lot more rules, a lot more thingies. I think I'm actually going to console log this out, and let's try input here. Let's go get our input, and let's run it. Okay, 6041. Let's give it a try. 6041. Cool. So before we move on, which I'm just going to do right now, let's take a look at our algorithm. For one, we pull in our data, but we do something a little different with it. First, we have to split the page rules and the updates by that double new line because we have that new line in the middle there. For the page rules array, we just create a map of it, and that's because memory is kind of cheap, and I wanted to be able to do the lookup much quicker, and so that's why I just left it as is. I know that I can actually generate this format as well very easily, so I just left it alone, didn't really mess with it. Then the updates, we go through each update, split it, do a double loop over it. There might be other ways of accomplishing this, but a double loop seems pretty simple. The plus I plus 1 is important here, so we don't loop over the same item twice, which in some algorithms doesn't make a difference. In this algorithm, you'd be saying a page needs to be printed before itself, which doesn't make any sense at all. Build our key. Again, pretty easy to do. Make sure if it does not exist, then it's valid. We assume it's valid until we find something that proves otherwise. If it is valid, we look up our middle index, add it to our total middle, and pop it in there. All right, let's go on to part 2. So what do we have here? We can try to fix the rest of the updates. Okay, so for each of the incorrectly ordered updates, use the page ordering rules to put them in the right order. Ooh, that's interesting. Okay. So you see these two swap, and these two, what are we swapping? Yeah, so they swap a couple of these actually. Yeah, so this is interesting because we do know basically the way that you would do this, I think, is you take this and say, okay, what's the first failure? Well, does this succeed? Yeah. This fails. Okay, then you swap those two numbers and you run it again, and you run it again, and you keep running until it succeeds. And just every time you get an issue, you just swap those two numbers, because swapping two numbers, like you saw here, these are now very different ordered. So 13, 75, and 47 all moved around. The 13 went to the end. So the first one you probably get is you probably run into 1375. Okay, so you swap those. That's there. That works. That works. That works. And then you get to the like 13. Well, that's interesting too because you might run into 29 and 47. No, you run probably 13 and like 29 maybe, and you swap those. So you just do a bunch of different swaps until you get something to work. So what that means, it's actually quite similar. Except what I want is I want to actually take this and move it to a function so I can verify it. Is valid. Update items. Okay. Equals. So now what we're going to do, we're going to start off here if, and then we're going to say if it's not valid. Okay. And actually, basically, if it's not valid, I want to loop until it is, but I don't want to actually add the middle unless it starts out valid. So let's do that. Okay, so put a let on here actually, and we say while is valid, attempt a fix. So the other thing I need here is I actually need to know why. Let's see. Oh, because let's call this check validity then. Or valid, because validity is a hard thing to write. Okay. This actually needs to let me know where the error is as well. So let's do this. Return true. And this one is going to be return false. And I actually want to know which key broke it. So I actually want to know this and this because those are, you know what, I just need to know I and j, don't I? Because those are the ones I'm going to swap. And I don't need this at all. Oops. Okay, so check if valid check 0, 0. So we're going to do I equals valid check 1, j equals valid check 2. And this is a pretty simple thing to actually switch. You need a temporary variable to hold one of them. And this is going to be update items of I, update of j, and then update items of j equals temp. Okay? And then we're going to loop again, and we're going to say valid check equals check valid. Update items. I could do this as a do while as well, but I'm not going to. And let's do this actually. Let's just log update items the whole time. And then break on that. And then I want to use my sample. And let's give that a try. Okay. That is kind of annoying. Because it didn't actually get here. All right, let's just double check this. Oops, I'm already there. Okay, so here's the first false. Oh, and then it fixed it. Let's check out the break then. Yeah, so you can see this one ran multiple times until it got there. And the middle is 1, 2, 3, which is actually correct. I'm really surprised that just worked. I'm very suspicious of that. I don't really trust it, but let's try it on input 1, 4884. Okay. 4. Okay. There we go. So let's take a look at the algorithm one more time. We do the same page map rules. That's totally fine. Then after that, we have our specific function to check if something's valid. But if it's invalid, it also tells us which particular items were invalid. Tells us those keys. Now in here, we check for validity. If we get an invalid one, while it's not valid, we take the two indexes that were valid and just flip them. And then we just keep doing that. Here's the actual flip code here, and then we just keep checking it until it's valid. And sometimes it takes a couple times, but the assumption here is that all of these can be valid based on the rules given. If there was ever a case that they couldn't be valid, we might have to add some code to verify if it's valid or not before doing this, or else we get an infinite loop. But that's basically that. And then same idea, we get the middle index added in, and there we go. Anyway, I hope this is interesting. Take care, folks. I'll see you next time.